Just like in our other discussions of geomorphology, we've talked about removal of material, transportation of material, and now we have to talk about the deposition of material. And just like those other agents, whether it's water or ice, what deposition is going to happen when the velocity or the density of the object causing the motion and transportation of other particles diminishes, so it can no longer hold that particle and it falls out of it, the ability to transport it. So again, we drop velocity, the biggest particles are going to fall first. As the velocity continues to diminish, sequentially the particles become smaller and smaller and smaller that are able to be transported. So the first features that we see starting to develop on a landscape that is a depositional landscape are usually ripples. Tiny little features which are only a couple of inches in height. They are linear, perpendicular to the direction of the wind. Rather common structure, and it's a common structure amongst and on top of larger depositional features, which are dunes. And so dunes then are the gross accumulation of sand from a blowout area or a deflation area. You can have singular dune environments. You can have areas which are where dunes are being formed, which are only a couple of feet in height, and then they come and they go. Or you can get sand seas, in which case the dunes have a permanent residency on the landscape. These dunes can function in structure in many ways, but at the base level, we could have dunes which are in constant rearranging and morphing into different shapes and different locations, or we can have semi-fixed or semi-permanent dune features dependent on what the wind conditions are like. So these dunes could have been created in a past condition when the winds allowed for the deposition to take place, but the winds over time may have resulted in a loss of wind velocity, which then is no longer high enough to then change these dunes. Or there is no longer a source area close enough to create these dunes by. So when we see ripples and we see dunes, there are some basic structures that we need to consider with a dune function. We've got a windward side in which the wind is moving up from, and we have a leeward face or a slip face. Most ripples in dunes have a angle of repose of about 34 degrees. And just like tree rings or just like coral or a stratigraphic volcano, we can see the genesis of these dunes by reading the layers that are in them. So the ripples start out here, and a ripple will then create just enough shelter to allow for more matter to start to accumulate. As more matter accumulates, the larger the structure that's going to become a dune will become. Eventually, we get this positive feedback mechanism that the larger the structure, the more sand gets accumulated. The more sand that gets accumulated, the larger the structure becomes, and so forth. These dunes have a characteristic morphology which does change. If the wind is unilinear, then we get a migration of dunes, where the windward side is the erosion side. Remember the vent effect that we talked about a little bit earlier. The dune itself becomes a vent effect because the side that generated the dune is also going to become the side that gets eroded. So the particles on this side skip and saltate along, or are pulled along through creep. They reach the slip face and then they fall down the other side, only to be redeposited again. So we get migration in a windward direction. If you've got a location where you have more than one wind direction, then migration gets complicated, and you may get direction of the dune, which will result in morphing the shape of the dune slightly, where you get coalescence of dunes, or you get a complete restructuring and rearranging of dune features. This is the kind of thing that we talk about. There are several dune shapes which are possible. The diagram here are the 6 most common. We've got Barkhan dunes, which occur when you've got a feature that acts as a barrier and slows down the velocity of the wind, allowing particles to fall out. And as that then creates the condition, we see accumulation in the center of that Barkhan, and then the wind transports and erodes the slip face here, and then pulls particles on either side of that dune. If you are a Battlestar Galactica fan, this reminds me of the Cylons. So think Cylon radar. Transverse dunes then, let me finish this off. So a Barkhan dune, these purple arrows are the direction that the wind is moving. So this is a unilinear wind direction. Transverse dunes can occur often when the Barkhan dunes start to change their shape and they coalesce together, and then you get these sort of unilinear ridges that occur, like ripples. And then what we can do is those Barkhan dunes that turn into transverse dunes are sort of in a mid phase where we're losing those little tails, we're losing these bits right here, and we're blending them together. They're starting to coalesce together. So you can see where we had a Barkhan dune in these arches and where they started to merge together. When you have, I've got one more dune that is unilinear, and this is a parabolic dune. And parabolic dunes actually occur because we have some type of vegetation or another structure which then offers some shelter, and then we get deposition within that center area, and then accumulation up the arms of that parabolic dune shape. Dual direction dunes, like a seraph, which is a sword, come from 2 different directions. These are seasonal winds that shift and change over time. Our environment sees seasonal shifts in wind direction. Sometimes they're out of the south, as they are in late summer and fall. The rest of the year, they're namely out of the west. So if we were a dry environment, we would likely have some volume of linear dunes created. And what ends up happening is these Barkhan dunes, after they're formed over one season, they get destroyed because the wind from another direction starts to pull that sand and rearrange the structure of the dune. So it never really creates a Barkhan shape. And as a result, what you get is a dune which is linearly parallel to the sort of middle direction, if you will, the mean direction between the 2 wind directions, which are common to this area. Last are blowout or star dunes, and this is a condition where you have multiple wind directions occurring. Oftentimes we're looking at places like a seashore where you have a coastal breeze and a sea breeze, or a land breeze and a sea breeze. So you get diurnal changes during the wind in combination with seasonal wind changes. So there isn't really any functional structure because there's so much change in wind direction that this place is always in constant morphing.